Today our topic is Quicksort. Quicksort is a divide and conquer algorithm. That is, the problem of sorting a set is reduced to the problem of sorting a smaller set. Each time we will sort a smaller set than the previous one. It divides the large array into smaller subarrays and then Quicksort recursively sort the subarrays. On the basis of divide and conquer approach, quicksort algorithm can be explained as first divide. Means what? The array is divided into subparts, taking pivot as the partitioning point. So from pivot you have to divide it. The elements smaller than the pivot are placed to the left of the pivot. The element which are greater than the pivot are placed to the right of the pivot. That is the divide approach. And what is conquer approach? Then the left and the right subparts are again partitioned by selecting pivot elements for them. Again do the same thing. This can be achieved by recursively passing the subparts into the algorithm. We will take an example, then it will be more clear for you. Now see how quicksort works. A quicksort first selects a value which is called the pivot value. Although there are many different ways to choose the pivot value, we will simply use the first item in the list. So, this is our list or array and these are the elements of the array and these are the index from 0 to 7 are the index and these are the elements of the array. And I am choosing the first one as the pivot element. So, here 25 is our pivot element. Now, what you have to do? You have to take two pointers. One is lower pointer, another is upper pointer. Lower pointer points to the starting element of the array and upper pointer points to the last element of the array. And what you have to do? You have to increase lower pointer till we get the element that is greater than the pivot element. And you have to do just the opposite. You have to decrease upper pointer till we get the element that is less than the pivot element. So, increase lower pointer. So, it is 57. Is 57 is greater than 25? Yes. So, stop here. Now, from the right hand side, you have to decrease upper pointer till we get the element that is less than the pivot element. So, 33 is greater than 25. So, skip. Then 96 is greater than 25. So, skip. 92 is greater than 25. So, skip. 12 is less than 25. So, stop. Now, what you have to do? Now, the pointer is here because 57 is greater than 25. So, stop here. And because 12 is less than 25. So, stop here. Now, what you have to check? You have to check what is the pointer position. Means the index of the array. Upper pointer position is 4 and lower pointer position is 1. So, is pointer position of upper is greater than lower pointer position? Yes. 4 is greater than 1. Then what you have to do? You have to swap between these two elements. Means where these two pointer points. That is, you have to swap between 57 and 12. So, swap between these two elements. Again, you have to repeat the same procedure. Means you have to increase lower pointer till we get the value that is greater than the pivot element, and you have to decrease upper pointer till we get the value that is less than the pivot element. So, this is our upper pointer. Okay. So, first 57 is greater than 25. So, skip. 37 is greater than 25. So, skip. 48 is greater than 25. So, skip. Now 12 is less than 25. So, stop. Now lower pointer. In case of lower pointer, 12 is less than 25. So, skip. 48 is greater than 25. So, stop. Now see the situation. Upper pointer cross lower pointer means two pointer crossed each other. What is the value where upper pointer points? It is 12. What is the position? It is 1. And what is the value where lower pointer points? It is 48. And what is the position? It is 2. See the position for upper pointer and lower pointer. Upper pointer position is 1, lower pointer position is 2. So two pointer crossed each other and the value of upper pointer is less than lower pointer. When the value of upper pointer is less than lower pointer, then you have to swap between pivotal element and where upper pointer points. I repeat, when the value of upper pointer is less than lower pointer, then you have to swap between the pivotal element and where upper pointer points. So upper pointer points here, here the value is 12 and pivotal element value is 25. So you have to swap between 25 and 12. See now, all the element right hand side of 25 are greater than 25 and all the elements left hand side of 25 is less than 25. So 25 itself find its position and all the element right hand side of 25 are greater, all the element left hand side of 25 are less. So this is the position for 25 after sorting. So now you have to repeat the same procedure for left hand side array, also for right hand side array. In this way, divide and conquer works. Now you have to take the left hand side array, repeat the same procedure. Again you have to choose the pivotal element and repeat the same procedure again. And you have to take the right hand side array, select the pivot element and repeat the same procedure. In this way, each and every element find its position and in this way, divide and conquer rule works on quicksort. So what we have done already, let x equals to a0. X is the pivot element, that is the first element of the array. That is, if the array is a0 is the pivot element. So x is pivot element. Let the element of A can be partitioned so that x is placed into the position j and the following condition holds. Now we partitioned it and x is placed at the position j. X is 25 and it is placed at the position j, that is where j value is 1. I repeat, x is 25, that is a0 and it is placed in the position j. J value is 1. Now the conditions, two conditions are each of the elements from 0 to j minus 1 is less than or equal to x. So each of the element from 0 to j minus 1. So if it is j, then left hand side of this j, it is from 0 to j minus 1 and right hand side is j plus 1 to n minus 1. If the total number of elements in your array is n, then right hand side is, this position is j, that is 1. So this array starts from j plus 1 to n minus 1. Total number of elements say 1, 2, 3, 4, 5, 6, 7, 8, 8. So maximum index is n minus 1, that is 7. So right hand side is j plus 1 to n minus 1 and left hand side is 0 to j minus 1. Therefore, x is the jth element of the sorted array. X is 25 and it is the jth element, j is 1 of the sorted array. If the foregoing process is repeated with the subarrays 0 to j minus 1 left hand side and j plus 1 to n minus 1 and any subarray is created by the process of iteration, the final result is the sorted file. So you have to repeat the same procedure for left hand side array, also for right hand side array. I am taking the right hand side first, okay, because left hand side there is, in our example, there is only one element. So I am taking the right hand side again. So this is our right hand side now. I have to repeat the same procedure again. Taking the first element as the pivot element, we start. There are two pointers, lower pointer and upper pointer. So you have to increase lower pointer till we get the element that is greater than the pivot element. Because 37 is less than 48, so skip. Because 57 is greater than 48, so stop. And for upper pointer, you have to stop till we get the element that is less than the pivot element, because 33 is already less than 48, so stop here. Now see the position for upper pointer and lower pointer. Upper pointer position is 7 and lower pointer position is 4. Because upper pointer position is greater than lower pointer position, so you have to swap between these two elements, 57 and 33. So swap between these two elements. Now again repeat the same procedure. Okay, you have to increase lower pointer till we get the element that is greater than the pivot element. So 33 is less than 48, so skip. 92 is greater than 48, so stop here. Now in case of upper pointer, because you have to decrease upper pointer till we get the element that is less than the pivot element. So 57 is greater than 48, so skip. 96 is greater than 48, so skip. 92 is greater than 48, so skip. And now see, two pointer crossed each other. 33 is less than 48, so stop. Now see, two pointer crossed each other. And what is the position for upper pointer and lower pointer? Upper pointer position is 4 and lower pointer position is 5. Upper pointer crossed lower pointer, two pointer crossed each other. When the upper pointer position is less than lower pointer position, then you have to swap between pivotal element and where upper pointer points that value. Means you have to swap between 48 and 33. So you have to swap. 33 comes here and 48 is here. Now see, all the elements right hand side of 48 are greater than 48 and all the element left hand side of 48 are less than 48. So 48 itself find its position. Now again repeat the same procedure. Take the left hand side array, repeat the same procedure. Take the right hand side array, repeat the same procedure. Take the right hand side array, make 92 as a pivotal element and repeat the same procedure also for left hand side array. And see, this is the position for 48 in the sorted array. In this way, divide and conquer works. If you repeatedly do the same procedure, you get the sorted array. Algorithm for quicksort. The objective of partition is to allow a specific element to find its proper position with respect to the others in the subarray. Each time pivot element gets its proper position. Two pointers upper and lower are initialized to the upper and lower bounds of the subarray respectively. So upper bound is if the total number of elements are n, then lower boundary is 0, that is the value of lower is 0, and upper is what? Upper is n minus 1. And pivot is a lower, that is a0, that is the starting element of the array. Repeatedly increase the pointer lower by 1 position until a lower greater than pivot. So you have to increase lower pointer by 1 until a lower means where lower pointer points, that value is greater than the pivot element. Repeatedly decrease the pointer upper by 1 position until a upper less than equals to pivot element. So you have to decrease upper pointer by 1 till we get the elements where upper pointer points a upper is less than equals to the pivot element. Now you have to check the position, that is the value of upper and lower. If upper greater than lower means you have to check the position, not the value of the array. It is the position, that is the index of the array. Upper and lower are the index of the array, not the value of the array. So if upper greater than lower, swap between a lower and a upper. Swap between those two values where lower and upper pointer points. So where lower pointer points that value of the array and where upper pointer points that value of the array. You have to swap between these two. The above process is repeated until the condition 3 fails. Condition 3 means this condition. If upper less than lower, if two pointer crossed each other, if upper less than lower, then what you have to do? You have to swap between a upper and pivot element and the value where upper pointer points. You have to swap between these two. Then pivot element get its proper position. I am writing one function for splitting. This is our array. There are 8 elements. So index starts from 0 to 7. So lower index is 0, upper index is 7. If there are n elements, then index starts from 0 to n minus 1. So lower index is 0, upper is n minus 1. These are the index and these are the value of the array. Now start writing our function. Function name is split. I am passing this array and the lower index and upper index. Lower index is 0, upper index is 7 in our example. Now this function returns the proper position of 25, that is the proper position of the pivotal element. So the return type is integer. It returns the proper position, that is the index of the pivotal element, from where you have to split our array into two parts. Okay, so the return type is integer. Now see, there are some integer variable I have to declare. I have to use it later. P equals to lower plus 1. P is the pointer. So P is this pointer. P, position of P is lower plus 1. So what is lower? 0. So P is, value of P is 1. That is the first index of the array. And Q is upper. That is the last index of the array. So what is the value of P? It is 1. What is the value of Q? It is 7. I equals to A lower. Lower is what? Lower is 0. So it is A0. A0 means the first element, that is I. I is the pivotal element. So what is the value of I? I is 25. So P is 1, Q is 7 and I is 25. So this is our pivot element, that is I. Now I start one while loop while Q greater than equals to P. Is Q is greater than P? Yes, 7 greater than 1. Then what you have to do? You have to increase P till the value of AP is less than equals to I. So increase P till the value of AP is less than equals to I. See here, AP means what? AP is 57. I is what? I is 25. Okay, so this condition false. So this pointer is here. And for this pointer, I have to check, is AQ greater than I? AQ means what? 33. Is 33 greater than I? Is 33 greater than 25? Yes. Then Q minus minus. So skip 33. Again Q comes here. Is 86 greater than I? Yes. 86 greater than 25. So skip this one. Then comes here. Is 92 greater than I? Means is 92 greater than 25? Yes. Then Q minus minus. So Q comes here. Is 12 greater than I? Means AQ means what? Q value is now 4. Is A4 greater than I? Means is 12 greater than I? Is 12 greater than 25? No. So stop. So this condition false. So stop. So this pointer comes here. Now this is the situation. Now you have to check the value of P and Q again. See, is Q is greater than P? Yes, Q greater than P. Then swap between these two elements, 57 and 12. So take a temporary variable T and swap between AP and AQ, means where P pointer points, where Q pointer points. AP means 57 and AQ means 12. So take a temporary variable, store the value AP to the temporary variable, store the value AQ to AP and store the value T to AQ. In this way, swapping is done. Now, what you have to do? Again repeat the same procedure. That is, again check this while loop. While Q greater than equals to P. Is Q is greater than P? Yes, Q greater than P. Then while AP less than equals to I. Now see, what is the value of P? P is 1. AP means A1. A1 means 12. Is 12 less than I? I means 25. Is 12 less than 25? Yes. Then you have to increase P. So P comes here. Now again this while loop. Is AP less than equals to I? What is the value of P? It is 2. So A2 less than equals to I. A2 means 48. Is 48 less than equals to 25? No. So this condition false. So P is here. Now we have to start from the right hand side, that is the second while loop, this while loop. While AQ greater than I, AQ means what? AQ means Q is what? 4. AQ is A4, that is 57. Is 57 greater than I? That is 57 greater than 25? Yes. So Q minus minus. So Q comes here. Now Q value is 3. Again you have to check this while loop. Is AQ greater than I? Q is what? Q is now 3. So is AQ greater than I? Means is 37 greater than 25? Yes. Q minus minus. Now Q is 2. So is A2 greater than 25? Is 48 greater than 25? Yes, 48 greater than 25. Q minus minus. Q is now 1. Is AQ greater than I? So AQ is now 12. Q is 1. So AQ is 12. Is 12 greater than I? No. So Q comes here. Now check if Q greater than equals to P. No. See, Q crossed P. So Q is here, P is here. Two pointer crossed each other. Q crosses P. So this while loop is also false. While Q greater than equals to P, this while loop is also false. So come out from this while loop. After this while loop, what you have to do? You have to swap between the pivotal element and 12 where AQ points. Okay, so between 12 and 25, that is where AQ points. So take a temporary variable and swap between pivotal element, means A lower is our pivot element, and AQ means where Q points, that is swap between 25 and 12. Now finally what you have to do, you have to first swap. Now see, all the elements right hand side of 25 are greater than 25. All the elements left hand side of 25 are less than 25. So you have to return the position of 25 where you have to split this array into two sub arrays. So you have to return the position, that is return the position of 25, that is Q, that is here in this case in our example it is 1. So you have to return the position of the pivotal element. Here in this case it is 1, that is Q. And from this location you have to split your array into two parts. Now the main function quicksort. In this function I have to pass this array A. Lower means 0, upper means 7. Means it is n minus 1. If the total number is n, then upper is n minus 1. Now check if upper greater than lower. Is upper greater than lower? Yes, 7 greater than 0 in our case. So call the function split by passing the array lower value and upper value. We already learned what is split function. So in the function split, I am passing the array, the lower value and upper value. And we already learned split function returns what? Split function returns the position of the pivotal element. I repeat, split function returns the position of the pivotal element. That is, 25 was our pivotal element. Split function returns the exact position of 25, that is 1. So split function returns 1. Now what you have to do? Now from here you have to split your array into two parts. Okay, that is you have to divide your array into two parts. Because all the elements right hand side of 25 are greater than 25, all the elements left hand side of 25 are less than 25. So split it. Now we get two parts. Now what you have to do? You have to do the same operation for the left hand side part, also for the right hand side part. So what was the value of I? Value of I is 1. So call the function quicksort. See how recursion works. By passing the array, the lower value, that is 0, and the upper value, that is I minus 1. I is 1. So 1 minus 1, it is 0. So call the function quicksort for left hand side array. A means the array. Lower value is 0. I minus 1, I is 1. So I minus 1 is 0. And for right hand side, again call quicksort function. See how recursion works. Here also you have to pass the array, and the right hand side part means here the lower value is I plus 1 and upper value is still upper. So it is A, I plus 1 and upper. So for first part, when we call the quicksort function, means for left hand side part, when we call the quicksort function, again you have to check whether upper greater than lower. But here upper value is what? Upper value is I minus 1, that is 0, and lower value is also 0. So upper equals to lower. Why upper equals to lower? Because there is one single element. When one single element is there, then upper equals to lower. And when there is one single element, no need to sort because there is only one element. So no need to sort. So 12 itself find its position. Now see the second part. For the second part, again you have to call, second part means the right hand side part. I plus 1, I plus 1 means here it is what? It is 2 and upper means what? It is 7. So from 2 to 7 again you have to call the quicksort function. Okay, so array lower is 2, upper is 7. Is upper greater than lower? Yes, upper greater than lower. So what is the pivot element? Here 48, and again call split function. Then 48 gets its position. Again you have to do two parts, left hand side of 48 and right hand side of 48. In this way this function works, and by recursion finally we get the sorted array. Now we will learn programming for quicksort. We already learned there are two functions in quicksort. First is the main function quicksort and second one is splitting. Now we have to learn how to call this function quicksort from main. So see the program. Two prototypes are declared, one for quicksort. The body of this function is written here, C, and another function is split. The body is written here. So we declare two prototypes here, and there is one array. It is an integer array, int A30. I declared this array globally because so that any function, whether it is main or quicksort or split, any function can access this array. So I declared this array globally, int A30. It is an integer array of 30 elements. Now see the main function. Here I declare two integer variable, lower and upper. I initialize lower value as 0 because it is the starting index of the array. Now I am taking how many number of elements are there in our array, supply the number of elements, user give n, means total number of the elements in our array is n. Now supply the elements. I am taking the value of that array by executing this for loop. For I equals to 0, I less than n, I plus plus. By executing this for loop, I get the elements. Now what is the value of upper now? Because we start counting from 0. So upper is n minus 1. Now I have to call the function quicksort. Quicksort by passing A means the array, lower means it is 0, and upper, what is the value of upper? It is n minus 1. And then after sorting, again executing this for loop, I print the array. Now see, this is the main function. And when I call the quicksort function, see the body for quicksort function, you have to pass the array A, lower value and upper value. We already discussed how quicksort function works, what is the coding for quicksort function, then call the function quicksort by from the main, okay, by passing the array name, lower value and upper value. And quicksort function calls split function here. And what is split function? How you have to write the code for split function? We already learned. So this is our split function. So now I am showing the total program. Just see. These are the prototype declaration and the global array. This is main. This is quicksort function. And this is split function. Now when I run the program, supply the number of elements is 6. So I am giving the elements 55, 11, 33, 22, 66 and say 44. So we get the sorted array. Now your task is to pause the video and try to run this program by your own. Now analysis for quicksort. Quicksort complexity analysis. First, worst case complexity. What is worst case running time? Assume first element is chosen as the pivot element. Assume array is already in sorted order. That is, this is our example. 11 is chosen as the pivot element and the array is sorted. So all the element greater than pivot element are after sorting are placed on the right hand side, and after sorting all the element less than the pivot element are placed on the left hand side. But in this case, because 11 is the smallest element of this array, so after sorting, what is the position of 11? Position of 11 is that the left hand side of 11 no elements are there, and for right hand side all elements are there because 11 is the smallest element. Partition split array in two subarrays. One subarray of size 0, that is no left subarray is there. The other subarray of size n-1, that is all elements are in the right hand side of pivot element. The worst case occurs when the list is already sorted. The first element will require n comparisons to recognize that it remains in the first position. Moreover, first sublist will be empty because pivot is the smallest one. But the second sublist will have n-1 elements. All the elements are in the right hand side of pivot. Accordingly, the second element will require n-1 comparisons to recognize that it remains in the second position. Same for third element will require n-2 comparisons to recognize that it remains in the third position, and so on. Therefore, total number of comparison is Fn equals to n plus n-1 plus n-2 in this way till 1. So, the result is n square plus n by 2, that is order of n square. That is the worst case time complexity. Now, the best case or average case. Quicksort achieves optimal performance if we always divide the arrays and subarrays into two partitions of equal size. That is, reducing the initial list, this is our initial list, places one element, places the pivot element, and produces two sublists. In the same way, reducing the two sublists, places two elements and produces four sublists. In the same way, reducing the four sublists, places four elements and produces 8 sublists, and so on. See the recursion tree, then it will be more clear for you. Total number of elements are n. Then after placing pivot element in its position, we get 2 n by 2 arrays. Then after placing two pivot elements in its position, we get 4 n by 4 arrays. And after placing 4 pivot element in its position, we get 8 n by 8 arrays. So, total number of comparisons will be n plus 2 into n by 2 plus 4 into n by 4. In this way, it is 2 to the power d into n by 2 to the power d, where n equals to 2 to the power d. What is d? D is the depth or height of this tree. So, it is n into d. What is the value of d? D is log 2 base n. So, the complexity for average case or the best case is order of n log 2 base n. So, in a nutshell, we can say that the worst case occurs when the list is already sorted. The first element will require n comparisons to recognize that it remains in the first position. Moreover, the first sublist will be empty, but the second sublist will have n-1 elements. Accordingly, the second element will require n-1 comparisons to recognize that it remains in the second position, and so on. Therefore, the total number of comparison is n plus n-1 plus in this way till 1, that is n square plus n by 2, that is order of n square. That is the worst case complexity. And best case and average case. Reducing the initial list places one element and produces two sublists. Reducing the two sublists places two elements and produces four sublists. Reducing the four sublists places four elements and produces 8 sublists. So, total number of comparisons will be n plus 2 into n by 2 plus 4 into n by 4. In this way, 2 to the power d into n by 2 to the power d, where d is the depth of the tree. So, n into d, that is n into, what is the value of d? It is log 2 base n. So, or it is order of n log 2 base n. So, this is your programming assignment. Write a C program to sort elements using Quicksort. First, try to run this program and feel free to ask any question in the comment section. This is your homework. Choose the correct option and answer me in the comment section what is the correct option. Pause this video, try to answer the correct option in the comment section. Pause the video, try to answer the correct option in the comment section. I am waiting for your reply. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.